Hi, Algebra 2 Trig Advanced students. Today we're going to continue day 2 for imaginary numbers, and we're going to review what I and I squared means at this time. I being the imaginary number. We use the imaginary number when we're looking for, let's say, the roots for a quadratic. They're not crossing the x-axis, these are floating. So basically, if it doesn't cross the x-axis, there's no real roots. So we use imaginary numbers to distinguish what those roots are. We started in class, we used I. We came up with I, we squared I on both sides. And we ended up getting I squared is equal to -1. I being equal to the square root of -1. So with these values right here, we have the square root of -7. We're going to split this up and get -1 times the square root of 7. And if you recall, square root of -1 right here is I. So we're going to rewrite that as I root 7. Okay. Then we have the square root of -16. So that's going to be square root of -1 times the square root of 16. So again, that's going to be I times 4, which we write as 4I. Square root of -20, again, -1 times square root of 20. Now, square root of 20 can be broken down to square root of 4 times square root of 5. And of course, this is I. So this being 2, and so that being 2, that being I. So far we have 2I square root of 5. Okay, square root of -t is going to be square root of -1 times the square root of t, which is I root t. Box that up. Okay. Talked about the complex number. Complex number is found by having a real number adding an imaginary part of the number. So we call this a complex number. There's value here. Okay. So with this, we have all of these are examples of complex numbers. You have 2 plus 3i. You have -5i plus no value, 1 minus i, and 2. This is actually 2 plus no value here for I. If I were to graph these on imaginary plane, which we call complex number plane, this is our real values here, and these are our imaginary values here. And then what we would do is we would plot each of these points. So here, 2 plus 3i, we'd go over 2 on the real plane and 3i up on the imaginary plane, and that point would be written as 2 plus 3i. -5i, 0, -5i, 3, 4, 5, that would be right here. Okay, 1 minus I, so over 1, down 1i, so that would be 1 minus I. Put that in parentheses. And then 2, just value right here at 2. I have some more values here that you could use. 3 plus 2i, so practice, over 3, up 2i, value right there. Put it in parentheses. 3 plus 2i. On a regular coordinate plane, you would use a comma, but we don't use that for on a complex number plane. -4 plus 5i. Okay, right there. Put the parentheses. Okay, 2 minus 3i, so 2 minus 3i being here. And then -2 to the left, down 6. All right, and that's it for graphing complex numbers. We're going to add complex numbers also, adding like terms, add real numbers with real numbers and imaginary with imaginary. 10 plus 3i. Need to distribute that negative sign. I think that's the cause of the most mistakes people make. Subtract 4 and then subtract 2i. 10 minus 4 is 6. 3i minus 2i is plus 1i. Is that it? Okay, I'm going to turn this a little bit. It's hard to write. This one right here is 2 plus i. So we're going to go, this is just 2 plus i plus 6 minus 4i. Combine like terms, we have 8. 1i minus 4i makes -3i, and then we're done. Nothing else to do with that. These are in A plus BI mode. Okay. This right here, we're multiplying complex numbers. Remember to take the negative sign out first. So that's really square root of negative 1 times square root of 2 times the square root of negative 1 times square root of 5. Now, square root of negative 1 is I times root 2. Square root of negative 1 is I times root 5. So what I really have is I squared times root 2 times root 5, which is root 10. So that's going to be negative 1 times root 10, which is negative root 10. Okay. For this one right here, we have the same kind of thing where we have square root of negative 1 times the square root of 9 times the square root of negative 1 times square root of 64. So what we have is I times 3 times I times 8. So we have I squared times 24. I squared is negative 1 times 24, which makes negative 24. This problem, we're going to FOIL, okay? And we are going to go 1 times 1, which is 1, plus 3i, let's see if I can erase that part. Okay. Let's see here, we did that. And then we're going to go 2i times 1, which is plus 2i. And then we have 2i times 3i, which is going to be 6i squared. Okay, that's still not there. Okay, and so now we're going to add like terms. Now this, though, I squared is negative 1. So what we have is 6 times negative 1, which is negative 6. So we have 1 minus 6. So 1 minus 6, which is negative 5. And then we have 3i plus 2i, which makes 5i. So we have negative 5 plus 5i. Okay, and then this one down here is going to be 3 minus 7i times 3 minus 7i, which makes 9 minus 21i, another minus 21i, and then we have a plus when we multiply these two terms together, 49i squared. Now again, I squared is negative 1. So this is really negative 1. So we're saying 9 minus 49, which is negative 40, and then we have minus 42i. Raising I to different powers. So a couple of things here. I, again, is the square root of negative 1. I squared is negative 1. Meaning if I were to take I is equal to the square root of negative 1, and I were to take this value and I squared both sides like that, I would get I squared is equal to negative 1. That's how you get that. I to the third power, we're going to write it as I squared times I. Similar to a variable, although I is not a variable, it's an imaginary number, but similar to that, you would keep the base and add the exponents, right? To get I cubed. So I squared is actually equal to negative 1 times I, which becomes negative I. Okay. We have I to the fourth power, which is the same thing as I squared times I squared, which is negative 1 times negative 1, which is 1. Now, something very interesting about I to the fourth power, and that is over here on this side, I'm going to go off on a little bit of a tangent. I to the eighth power is the same thing as I to the fourth times I to the fourth. Now, anything to the fourth power is 1. So we really have 1 times 1, which is 1. And that's this value down here. But my point is that anything that is divisible by 4 is going to be 1. Meaning if I have I to the 20th power, that's the same thing as saying I to the fourth, I to the fourth, I to the fourth, times I to the fourth. Well, that's just 1 times 1 times 1 times 1. It's 1. So like if you were saying I to the 100th power, that's 1. If you were saying I to the 24th power, that's 1. So you always try to take as many 4s out as you can. I to the 5th power, we're going to say that's I to the 4th power times I, which is going to be 1 times I which is I. And then I to the 6th, again, I to the 4th times I squared. So that's 1 times negative 1, which is negative 1. Some of you are seeing a pattern here going down, negative 1, negative I1, etc. I to the 7th is going to be I to the 4th times I squared times another I. So again, that's 1 times negative 1 times I. And so that makes negative I. Okay? And I to the 80th power, again, 80 can be divisible by 4 evenly. And so that's going to be I to the 4th power 20 times. So we really don't even actually need to write I down because we know that that number is just 1. Okay, I to the 37th power, you can say that that's I to the 36 because I know 4 goes into 36 times 1 I left. And so that's actually 1 times I, which is I. And then we have I to the 58th power. How many times does 4 go into that? Does 4 go into 58? So you take 4. Does that go into 58? No. So you have 4, 1, 8. Nope, that doesn't go in there evenly. So let's try a different number. How about 56? 4 goes into 56. Does it divide in? 1 time here. Subtract 4. We have 1, 6. 4 goes into 16, divides in. So we know that 4 will divide into 56. So we can say I to the 56th power and take out that many 4s out of 58, and now I have 2 left. And so now I have a 1 times a negative 1, which is negative 1. I to the 75th power is I to the 72. I can take out 4 divides evenly into 72 times I to the 3rd power. This is 1. So what we have is 1 times I to the 3rd power, which is, we're going to call that I squared times I. And I squared is negative 1. So we have 1 times negative 1 times I, which is negative I. Lastly, I to the 44th power is 1 because 44 divides evenly with 4. Let's see, complex conjugate. We talk about conjugates being the opposite value on the inside. So for example, if you have negative 3 plus 7i, the conjugate to this value would be negative 3 minus 7i. Leave the negative out front. We're only changing the value inside, not the value outside. This one right here would be 4 plus 5i. The reason why we do this is so that we can multiply and lose the middle term, or lose all the imaginary numbers if this was, let's say, on the denominator. So let's do this. 5 times 5 is 25. 5 times 7i, 5 times negative 7i is negative 35i. This 7i times 5 is plus 35i. And then we have 7i times 7i, which is negative, negative times positive negative, 49i squared. So what we have here is these values right here canceling themselves out. That's going to happen every single time you multiply by the conjugate. Now we have left 25, and then remember that I squared is negative 1. So what we have is 25 plus 49, and that's going to be 74. So dividing complex numbers, again, with the same thought of what we just did here on the previous page. See how we started with 7 i's, minus 7i, 5 plus 7i. What we're doing right here is we lose the imaginary number here. That's what we want, because you can't have an imaginary number on the denominator. Imaginary numbers are like radicals. They're not allowed to be on the denominator. So we're going to fix this, and we're going to actually multiply by the conjugate. And in that case, it's going to be 1 plus 6i, 1 plus 6i. Because you really can't just change an expression. You have to multiply it by 1, but it can be in different forms. So I'm going to FOIL 2 times 1, we have 2 plus 12i minus 5i minus 30i squared. And this is all over 1 plus 6i minus 6i, and then minus 36i squared. So this is going to become, let's see here. Remember the I squared? I squared here is actually negative 1. So I have negative 30 times negative 1, which makes positive 30. So 30 plus 2 is 32. And then I have these two common imaginary numbers. 12i minus 5i is plus 7i. And then I have these two canceling out. Remember, I squared is negative 1. And so this is negative 36 times negative 1, which is positive 36. So we have 1 plus 36, which becomes 37. So this would become our answer to this expression. And you also could rewrite it like this: 32 over 37 plus 7i over 37. And that's another form where we split the denominators up. Same thing. These are called literal equations, and we want to solve for different values. The first one that we're going to solve for is b sub 2. So to isolate the b sub 2, we're going to slowly move everything else away from that. So that's 1/2. I'm going to multiply by 2 over 1. Those are gone. I'm going to divide by h. Those are gone. So right now I have 2a over h. Okay. Equals b1 plus b2, b sub 2. I'm going to subtract the b sub 1. So now I have 2a over h minus b sub 1 is equal to b sub 2. And that's what I wanted. So that becomes my answer. Okay. Here, I'm going to solve for b. But I do notice that I have b's on both sides of the equation. So I'm going to combine those. So let's see, I'm going to move this 2b over to that side, and I'm going to move this 3 to that side. So what I have now, let's see here, is a minus 3 equals 2b plus bcd. Yeah. And 2b's, I'm going to take out a b. And by taking out a b, I have left 2 plus cd, and that equals a minus 3. And then, well, the b is all by itself, so all I have to do is divide both sides. So if I divide both sides by 2 plus 3d, that becomes my answer. b equals a minus 3 over 2 plus 3d. Okay. This problem looks a little bit tricky, but it's not awful. We have 3x minus 2, 4 minus 2x minus 2. Always do the insides first, okay, inside out. Let's see here, 4 minus 2, that's 2. So I have 2 minus 2x inside here. And then you're going to distribute this times this. I'm just working on the left side right now. So I have 3x, let's see here, minus 4 plus 4x. So that's what? 7x minus 4. On the right-hand side, let's see, we have 2x minus 3, 1. Now we're going to distribute the inside part here. So we have plus 2 minus 2x. And I'm going to multiply the 3 through, but at first I'm going to simplify and make that a 3. 2 plus 1 is 3. So we have 2 times x, let's see here, through negative 3 times 3 is what? Minus 9. And then 3 times negative 2 becomes plus 6x. That's 7x. Let's see. So we have 2 times 7x minus 9, which becomes 14x minus 18. Keep simplifying. I'm going to move the 7x to the right and subtract 7x from both sides. I'm going to add 18 to both sides. So I get 7x equals 14, x equals 2. Okay, these are different ways to solve a quadratic, either square rooting both sides, factoring, quadratic formula. You can graph, or you can complete the square. We're going to try all of those, not all at the same time though. Just solving by factoring. When I say solve, what I'm asking you to do is to find the x-intercepts. Another name for x-intercepts are roots or solutions. So when I say solve, I'm asking you to do all three of these things here. They're all the same thing. Solving by factoring, if I'm actually asking you for the x-intercepts, you have to set y equal to 0. So now we have x squared plus 3x minus 10. It tells me to solve by factoring, so that's going to become, let's see, x plus 5 and x minus 2, what multiplies to be negative 10, but adds up to be 3. So that would be 5x and negative 2x. We're going to split this up. You go x minus 2 is equal to 0, so x equals 2. We have x plus 5 equals 0, x equals negative 5. My solutions are negative 5 and 2. And again, when I say solutions, I'm saying my roots are negative 5 and positive 2. These are on the x-axis. My y-intercept is negative 10, and I get that because I set x equal to 0. So you can make a note to yourself, set x equal to 0. So at negative 10, which is, let's say, right about here, so my graph probably comes down like this and comes back up. Now, the question wasn't to find the vertex. We could definitely find the vertex if we needed to, but it didn't ask us to do that. Solve using the quadratic formula. Before doing this problem, I would probably divide everything by 2 to simplify. Always look out for values that are common in between these to reduce. So we have x squared plus 4x plus 5 is equal to 0. Now, it's asking me to use the quadratic formula. I really couldn't factor that if I tried, because 5 times 1 is the only thing that multiplies to be 5. But when it adds up, it's not going to become 4. It's going to be 6. So I actually can't use the can't factor this. I want you to remember that this equation right here comes from the standard equation, y equals ax squared plus bx plus c. Notice that the a term is in front of the x squared term, the b is in front of x, and c is the constant value. Y is 0 because we're trying to solve. And again, solve, I'm trying to find the x-intercepts, okay? So when I plug this into my quadratic formula, which is this, negative b plus or minus b squared minus 4ac all over 2a, okay? We're going to go x equals negative b. So if b is 4, it's the opposite of 4. So negative 4 plus or minus the square root of b squared. So that's 4 times 4 is 16. Minus 4 times a is 1. That's that value right there. Times c, which is 5, all over 2a, or 2 times 1. This becomes x equals negative 4 plus or minus. Now this looks like 16 minus this right here is all one value, 20. So that's going to be negative 4 all over 2. Now, square root of negative 4 is imaginary. Square root of negative 4 is actually the square root of negative 1 times the square root of 4, which is I times 2, 2i. So what we really have here is negative 4 plus or minus 2i over 2. And I can even simplify that more and make that negative 4 over 2 plus or minus 2i over 2, which becomes negative 2 plus or minus I. And just a note, I want to talk to you about using this same value and x squared plus 4x plus 5 and completing the square, both sides and squaring both sides. So I'm going to show you how to do that really quick here. Okay. We're going to take the same equation, which is x squared plus 4x plus 5 equals 0. And I'm going to subtract 5 from both sides. So now we have x squared plus 4x is equal to -5. And in doing this, okay, what we're trying to do is complete the square. And we talked about completing the square the other day, but we're going to try this for solving the quadratic. We're going to take half the value of 4. So half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. Again, what I did was I took the b term and I divided it into 2, and then I squared it. And then I'm going to add that to both sides. So again, half of 4 is 2. 2 squared is 4. So I'm going to add 4 to both sides. This is going to factor to be x plus 2 times x plus 2, which becomes x plus 2 quantity squared, and that equals -1. And so right now what I'm going to do is what I was talking about is square rooting both sides. Square root of -1 is plus or minus I. Square root of x plus 2 quantity squared is x plus 2. And so all I have to do is move that 2 over to the other side and becomes -2 plus or minus I. Same answer. Graphing quadratics, you know the y-intercept. Set x equal to 0. This becomes my y-intercept at 8. So we'll put that value right there. This is just another way of graphing. So you can plot points into this equation. So if you plug in -2, you would go -2 squared minus 6 times -2 plus 8. So that's going to be 4 plus 12, which is 16. 16 plus 8 is 24. So I have a point at -2, 24. Plugging in -1, we get -1 squared minus 6 times -1 plus 8. So we have 1 plus 7, or excuse me, 1 plus 6 is 7, and 7 plus 8 is 15. So at -1, we're at 15. So that's there. At 0, we have 0 squared minus 6 times 0 plus 8. That's just 8. Plugging in 1, we have 1 squared, which is 1, minus 6 times 1 plus 8. So 1 minus 6 is -5. -5 plus 8 is 3. So at 1, we're at 3. Yeah. At 2, we're going to get 4 minus 6 times 2 plus 8. 4 minus 12 is -8. -8 plus 8 is 0. So at 2, we're at 0. At 3, we have 9 minus 6 times 3 plus 8. So that's what? 9 minus 18, which is -9, plus 8, which is -1. So at 3, we're at -1. Now, I don't really see a value. I don't see myself coming down. Oops. Okay, well, let's see. Let's move this down a little bit. There we go. That's better. We need to see where this is actually turning around. So I'm going to pick, let's say, 5. So if I picked 5, I would get 25 minus 6 times 5 plus 8. So we'd have 25 minus 30, which is -5, plus 8, which is 3. So we had 1, 3. So at 1, we're at 3. And so now we're at 5, and we're at 3. So it looks like this is coming down to here, and then turning around and coming back up. Okay. All right. So as you notice in this problem right here, the vertex, it does look like the vertex is at 3, -1. However, just to be sure, is that the place where this line, which is called the axis of symmetry, cuts the graph in half. There's another way to be a little bit more accurate, okay, to find the vertex, and we call this the shortcut. It's -b over 2a, and then we plug it in. And you get that, again, from y equals ax squared plus bx plus c. Please make sure that you take the value in front, the sign in front, to for each of the values of b or a or whatnot. So -b, so the opposite of b. So let me write this out on the side. So a is 1. That's the value right here in front of the x squared term. B is equal to -6. C is equal to 8. Okay. We also, again, the same problem. We know that that's 8 here. We're going to say negative b, so the opposite of b, which is going to be positive 6 over 2a, so 2 times 1. So this becomes 6 over 2, which is 3. Now, once we have that value, we're going to plug it in. Oops. We're going to plug that into our equation. Okay. Alrighty. We're going to plug that in right here. And here's the equation that I'm going to plug it into, original. So we're going to go y is equal to 3 squared minus 6 times 3 plus 8. So we have 9 minus 18 plus 8. So y equals negative 9 plus 8, which is negative 1. So my vertex is going to become 3, negative 1. Now, 3, negative 1 being here, that's my vertex. That right there is going to give me my axis of symmetry, which basically takes my graph, turns it back around, makes it a symmetric value over here, comes down, comes back up. Okay. Sorry about that. Let's try to get that a little bit better. Okay. All right. A couple of things here. The axis of symmetry is x equals 3. It's a line. It's an equation of a line. We get this value from the x coordinate on your vertex. Okay. Find the vertex and graph the parabola using the shortcut method. So we're going to use the shortcut method. We have y equals 3x squared plus x minus 2. We're going to use the shortcut method, which is negative b. So if a is 3, we know b is 1, c is negative 2. Sometimes that helps to write all this out. That's up to you. So the opposite of b is negative 1 over 2a. So this is actually negative 1 over 6. I'm going to take that value and plug it back into the equation. And so I'm going to have y equals 3 times negative 1 over 6 squared plus negative 1 over 6 minus 2. And that's going to be y equals 3 times 1 over 36 minus 1/6 minus 2. And this 3 will divide into 36 12 times. So you get 1/12 minus 1/6 minus 2. And for this problem, I need a common denominator before I can add all these fractions up. So I'm going to multiply by 2 over 2. And this one, 12 over 12. So I have 1 minus 2. So I have 1 minus 2 minus 24. And so what is that? Negative 25 over 12. So that value is my y coordinate for the vertex. So negative 1/6, negative 2 and 1/12. So that's about right here. And I know my y-intercept is negative 2. So this value here, that's my vertex. There we go. So when we graph this, this is going to look like this. I am going to have an axis of symmetry down the middle. And again, it is always the x coordinate. So x equals negative 1/6. Okay? For my axis of symmetry. And my vertex, let's see here. Oops. Okay. Complete the square to find the vertex. Now this one, to find the vertex, we can use the shortcut method. But the other way we can find the vertex is to complete the square. So again, to find the vertex, you can use the shortcut, or you can complete the square. Okay. So in completing the square to find the vertex, you don't lose the y. You're going to lose the y. Y is going to go to 0 when I'm looking for x-intercepts. But I'm not looking for x-intercepts. I'm trying to find the vertex. So we're going to try to put our equation in what's called vertex form. So the first thing you're going to do is move this 8 over here. You're going to isolate your x's. So you're going to go y minus 8 is equal to x squared minus 6x. again, the steps, isolate the x, both of the x's, and then remember, we're going to take half of the b term, and then that value, we're going to square it. And then we're going to add that to both sides. So that's sort of our guidelines of what we're doing. So take half of the b term, so -6 divided by 2, which is -3. We're going to take that value, square it, and then we're going to add that to both sides. Okay, so what is this going to be? Y plus 1 is equal to, and this will be x minus 3 times x minus 3. This is always going to be perfect square here. So y plus 1 equals x minus 3 quantity squared. Put this in vertex form. We want to move that 1 over, that's all. X minus 3 quantity squared minus 1. This is what we call vertex form. Okay. And then what we're going to do is we're going to use to find the vertex, which is 3, -1. So that when I graph this, if I were to graph, I would go over 3, -1. I know that my y-intercept is 8, so way up here. So this is my graph, going up like that and going up like that. Lastly, I would just make sure I knew how to find the axis of symmetry. Okay, and that's a line that goes through the x-axis for this problem. And the x coordinate, which is 3, x equals 3, is my axis of symmetry. Okay. Find the vertex by completing the square. Again, isolate your x's, so move the 6 over. Okay. We have y minus 6. I'm going to take half of 8. Half of 8 is 4. 4 squared is 16. I'm going to add 16 to both sides. It's an equation, so whatever you do to one side, you have to do to both. So we have y plus 10 is equal to, and this is going to factor every time perfectly, x plus 4 times x plus 4. It's, square root of this and the square root of this. That's your values. They go into the parentheses. X plus 4 quantity squared. Y plus 10. I'm going to move that 10 to the other side. Put that in vertex form. So my vertex is going to be -4, 10. And if we were to graph this, -4, 10. So -4, 10. Let's use a different color. -4, 10 being here. Okay, my y-intercept is 6. Oh, I see what the problem is. When I took this positive 10 and I moved it to the other side, this should have been negative. So the reason I was looking at my graph, because if this is my vertex, if this is positive, my graph has to go up like that. And so what I need to do is I need to fix this. That should be I need to fix my graph a little bit. So this should be minus 10, negative here. And so at -4, -10, I like that better. Because what that does is it gives me my vertex down here at -4, -10. And then my y-intercept is still 6. So this graph is going to come up like this. And then go like this. We're going to have an axis of symmetry that cuts right down the middle, right here. And again, always going to be your x coordinate of your vertex. So x equals -4 is my axis of symmetry. And our vertex, we found that. Okay. Use the quadratic, or graph the quadratic, find the vertex by completing the square. So one of the problems is that there's a negative sign here. Okay, so I'm going to isolate the x's. So what I'm going to do is I'm going to get y minus 10 is equal to x squared plus 12x. Okay, and when I'm doing that, I lost my negative sign. When I do that, you can't complete the square if there's a negative sign in front of the x squared term. So what you're going to have to do is you're going to have to factor that out. So I have x negative parenthesis x squared minus 12x. And then here, this is still y minus 10. Half of 12, now I'm going to complete the square. So half of 12 is 6. 6 squared, it's negative 6, but 6 squared is 36. So I'm going to add negative 36. See this negative sign here? That has to be put back in. You multiply it back in. So this is plus negative 36 to both sides. So I have y minus 46 is negative. This is going to factor x minus 6 times x minus 6. And so I have y minus 46 equals negative x minus 6 quantity squared, y minus 40, excuse me. I'm just going to move the 46 to the other side. And so I'm going to get y is equal to negative x minus 6 quantity squared, and then add 46. So that my vertex is going to be positive 6 and positive 46. So 6, 46, we'll just say that's way, way up here. So let's say that's 46. My y-intercept is 10, which if that's 46, we'll say 10 is way down here. And I'm looking at my negative graph. This being the vertex, this is going to come down like this. And then this is going to come down like that too. I am going to have an axis of symmetry down the middle. And again, my axis of symmetry will be x equals 6. I didn't ask for these two values right here, which are the x-intercepts. I could find the x-intercepts, but I didn't ask for those for this problem. Graphing, again, y-intercept is going to be negative 3, set x equal to 0. So at 0, we're at negative 3. You can plot more points. Plugging in negative 2, you get negative 2 squared minus 2 times negative 2 minus 3. So we have 4 plus 4 minus 3. So 8 minus 3 is 5. We have negative 1, so that'll be 1 minus 2 times negative 1 minus 3. So 1 plus 2 is 3. 3 minus 3 is 0. Plugging in 1, we get 1 minus 2 minus 3. So that's going to be 1 minus 5, which is negative 4. Plugging in 2, we get 4 minus 4 minus 3, so which is negative 3. Plugging in 3, we get 9 minus 6 minus 3. So that's going to be 3 minus 3 is 0. Okay, let's see what we get. Negative 2, 5. We get negative 1, 0. We get 0, negative 3. We get 1, negative 4. We get 2, negative 3. And we get 3, where are we at? 0. So it looks like my graph is doing this. Okay. Okay, so that concludes what we did on day 2. Just keep in mind, this problem just says graph. I wasn't specific as far as finding the vertex or finding any x-intercepts. If I asked you to find the vertex, note that I could do that by completing the square. So I can make that y plus 3 equals x squared minus 2x. I could take half of 2 is 1. 1 squared is 1. Add that to both sides. Y plus 4 equals x minus 1 squared. Rewriting that, I get y equals x minus 1 quantity squared minus 4. So my vertex would be 1, negative 4, which is this value right here. And you can keep in mind that those values are usually the turning point. So what we have for my line of symmetry, axis of symmetry, is x equals 1. Again, that comes from that value right there. If I wanted to find the x-intercepts, I could factor. One way I could either factor, let's see, if I wanted to factor, I would get, let's see, set y equal to 0. So 0 equals x minus 3 times x plus 1 would make -2. And, okay, splitting this up, we would get x minus 3 equals 0, so x equals 3. We would get x plus 1 equals 0, so x equals -1. My x-intercepts are -1 and 3. Keep in mind that when you're finding your x-intercepts, it's when y is equal to 0. So I could have just looked right here and said, oh, there's one of my zeros. Here's another one of my zeros, okay? Instead of having to factor. Okay, so use some common sense for that too. I hope that helped you for day 2, imaginary numbers, and I'll see you tomorrow in class. Thank you very much.